Good evening, students. In this video, I have informed about how to write the procedure for the salt analysis, and that to particularly inorganic salt analysis. So generally we do the salt analysis, we identify the acid radical and the basic radical, and then we skip on to the writing the procedure process. So here is an example how to write a procedure for the salt analysis. So first of all, whenever you write in your exam point of view, you have to write the procedure by splitting the paper into three columns as named as experiment, observation and inference column. So well, you would have done the salt analysis and you will be knowing the acid radical and the basic radical, and you need to write the procedure for your acid and basic radical obtained. So basically any salt, the format of writing is the preliminary thing should be entered in the procedure part, that is color of the salt, appearance of the salt and the solubility. This is actually not essential as we concern for the board exam, but a format of writing the salt analysis will begin from this part of it. So color of the salt, it should be known. Generally for higher secondary classes, we normally prefer colorless salts, so that is white colored salts. So white colored salts, in the sense we have many white colored salts, so out of that we would have listed very few. You can see here in the experiment column I have written color of the salt is noted, and your observation will be colorless. Don't write white color, it is colorless in nature. So therefore what do you infer from that, that is what do you obtain from that, what do you identify from that? Maybe presence of, maybe presence of, we are not identifying directly, it might be presence of. So maybe presence of, it might be aluminum salts, it might be zinc salt, it might be magnesium, it might be barium, it might be calcium, it might be ammonium, it might be strontium, anything of the salt. So roughly we'll be writing these radicals over there. The second part of the procedure is writing appearance of the salt. So how does salt appears to be? Basically we know salt might be either crystalline or powdery nature. Since we have done a salt over here and have entered here, it is crystalline. Therefore the second set of things is appearance of the salt is noted, which is crystalline, in the observation column should be entered. If it is crystalline, so then your inference will be maybe presence of sulfate, chloride, nitrate, or it might be bromide or even oxalate also. So depending upon the radicals, you may list any one among, you may obtain any one among this. So you'll be writing all the radicals whichever it's been present over there. And third part comes to be solubility. So well, you know, crystallines also basically soluble in nature. So generally to a little amount of the salt 10 ml of distilled water is added, and what do you observe from that? Your salt is soluble in nature, your salt is soluble. Therefore if it is soluble, you might contain sulfate salts, chloride salts, nitrate, bromide or oxalate. So these are the three preliminary things in which a salt format has to be entered. Okay, as exam point of view, you can skip, or generally if you want to write for a salt analysis, this is the three important thing which you have to write, and then you have to begin with your respective remaining tests over here. So then since my salt is obtained, and whichever is applicable for you, you'll be writing for the procedure part. So since my salt, you can see here towards the inference column I have entered here barium, so therefore barium comes and it answers in the flame test. So here you can see the flame test with the experiment. A little amount of salt is taken in a watch glass and 2 drops of concentrated HCl, maybe 1 or 2 drops is added, and using a glass rod, generally you can use a glass rod or a platinum coil, and it should be made into paste, a solid paste, and it should be taken and introduced into the non-luminous flame of the Bunsen burner. So non-luminous flame in the sense blue color flame we should be introduced. So when we introduce this mixture, the solid paste, you can observe that apple green flame is obtained, an apple green flame is obtained. So this gives us an idea whether that might by salt might contain barium radicals. So therefore you'll write in the inference column maybe presence of barium. We are just getting a rough guess, it might be a presence of barium. So moving on to the next test, we need to go ahead with the preparation of sodium carbonate extract. So generally this process will almost reduce most of the unwanted ions which has been present in a salt. So how to prepare the sodium carbonate extract? So you all know well, to 1 gram of your salt, 3 gram of sodium carbonate is added, and 20 ml of, depending upon the amount of water you require and depending upon amount of salt solution you require, we'll be adding the amount of water. So therefore, to 1 gram of salt, 3 gram of sodium carbonate is added, and 20 ml of distilled water is added and mixed thoroughly, these mixtures. Then the content is added in the beaker. Content which is present in the beaker is heated, boiled, and then the contents are cooled, and finally it is filtered. Thus the filtrate which is obtained is known as sodium carbonate extract. To carry out the remaining test, we'll be progressing with this sodium carbonate extract. Yes, so this is the beginning part of your salt analysis. As we move on to the next test and all, you can observe here, since my salt is chloride, so straight away I'll be just going for concentrated sulfuric acid test. So you all know well, to a little amount of salt, concentrated sulfuric acid is added. You should be very careful when you add concentrated sulfuric acid. As and when you add concentrated sulfuric acid to your salt solution, you can observe white fumings which produces pungent smelling gases, which releases a dense white fumes when you keep the mouth of the ammonium hydroxide bottle and near to the test tube. So this confirms, or this gives you an idea about the presence of your chloride radical in your salt. Chloride radical in your salt. So if it is chloride radical, I have to confirm. Therefore the next part will be the confirmatory test for acid radical. You can observe here, confirmatory test for acid radical. So we have a very good test which can be performed to confirm my chloride salts. So I'll be performing silver nitrate test. So how do I prefer silver nitrate test? To 1 ml of the extract which has been prepared, a little amount of dilute HNO3, that is, in order to expel carbon dioxide and in order to acidify my salt, I am adding this dilute acids, because it's their derivatives of their respective salt radicals which has been added. So therefore, to 1 ml of the extract, a little amount of dilute HNO3 is added, and it is ensured that the carbon dioxide gas is expelled. And to this content, we are adding little amount of silver nitrate solution, and you can observe a curdy white precipitate is obtained. A curdy white precipitate is obtained, and in which in turn, which is soluble in excess of ammonium hydroxide is formed. Excess of ammonium hydroxide is formed. This confirms the presence of chloride radical in my salt. Therefore, my acid radical present in the salt is chloride. So this is how I'll confirm the acid radicals. Like this, we have for sulfate, we can prefer barium chloride. For nitrate, we can prefer brown ring test, and we can prefer for acid test for carbonates and our respective radicals. Okay, since my salt is chloride, I'm preferring silver nitrate test. So then moving on to the next one, we found out acid radical. What is left out in the salt? It is basic radical. So in order to identify the basic radical, I need to prepare the original solution. As per the procedure is concerned, it should be entered. So thus I have labeled it as preparation of original solution. So how do we prepare original solution? So generally, to 1 gram of salt, 10 ml of distilled water is added. Thus original solution is prepared. So since my salt is crystalline, in the preliminary I saw my salt was crystalline and hence it was soluble. Sometimes in exam or when you do, you might get a powdery salt. So how does a powdery salt has to be prepared into original solution? So basically, powdery salts are insoluble, so I will not be using distilled water for the preparation of original solution. At that time, what I need to do, I need to make use of the concentrated acids. So to 1 gram of the salt, I'll be adding a concentrated nitric acid. So that's the original solution for powdery salt can be prepared. Since my salt is chloride, it should be basically crystalline. Therefore, I'll be adding distilled water, and that's original solution is prepared over here. Then comes the group separation, the important section of the salt analysis, because acid radical has no problem that we have very few acid radicals, but basic radical, since it is a simple salt, it's quite easy, and there are salts which is in the form of complex form. Okay, more than one radicals will be present, but here it is important to ensure the group separation radicals. So group separation, so we need to know where is my salt and which group it comes. So we have 6 groups, and in that 6 group, any one of the group my salt can be positioned. So to identify this salt, I have to go for